Hello, everyone. Really appreciate you coming to listen to my talk. I'm going to share 10 tips, and maybe somehow I'll sneak in a few more than that as we go through it and answer some questions, but at least 10 tips that I've learned running a series of Python web apps in production for the last 5 years or so. Now, first question often people ask is, how do I get the code that I see you type up here? So there's going to be a GitHub repository that you can get the code from. I'm showing you this now, so Josh doesn't get a ton of questions, but I'll be sure to throw that into the show notes, not the show notes, into the conference notes or the Slack at the end. It's also at on the last slide. So you'll be able to get what we're working on here. There'll be some live demos. There'll be some just high level stuff as well. So we're going to talk about these tips, and let's just jump into the 10 tips. But first thing before we do, yeah, I've been running a Pyramid web app. I've also been doing a little bit of Flask API stuff as well. But these tips, for the majority, apply to all the frameworks. Okay, so whether you're doing Pyramid or you're doing Flask or Django, or if you're living out on one of the newer frameworks, the cutting edge stuff, Fast API or Sanic or something like that, for the most part, these tips are generally applicable, but I'll show you what we're doing in our Pyramid apps. The first one is security. Now, Haley talked about security yesterday and had some really good ideas. And I want to start off by showing you something that is incredibly simple for you to add a whole bunch of security to your web app. And this is this thing called secure.py. And I really like it because it keeps up with the security things that you need to do, and you don't necessarily have to worry about them. As the package updates, it'll get new features. And in general, it's based on this thing called OWASP. So if you've heard of OWASP, it's probably around their top 10 web security vulnerabilities. So they're the Open Web Application Security Project, a nonprofit organization. And they publish this updated list every year that says, this year, here are the 10 most common reasons that people get hacked. And you can imagine that things like SQL injection attacks and whatnot are still in there. That's not something that SecurePy would help with, but there's a bunch of other more nuanced things that don't have XKCD, little Bobby tables type of jokes about them, right? They're, I guess, more subtle, but also possibly more serious, cross-site scripting, embedding iframes, and then covering them up with like transparent overlays that do all sorts of stuff. All right, so there's all these things that you should be doing for your app, and let's go check this out and see how secure.py will help us. All right, so secure.py, open source thing over here, and what's cool is it adds secure headers and cookies for Pyramid web frameworks. So it's a Python web framework. So not just Pyramid. If you go down here, you could see AIO, HTTP, Bottle, CherryPy, Pyramid, Flask, Sanic, a bunch of these different frameworks here. Excuse me. So it's really easy. You just install it. And then if you want to use the secure headers, which is the one that does most of the magic for you, it'll set things like disallow embedding your site as is in an X frame inside of another site that might take control over it, and cross-site scripting and all sorts of stuff. So let's go real quickly and look at an app. That's interesting, but not what we're looking for. Let's go look at the first app here. So this is just basically, I went to Cookie Cutter and I said, create me a new Pyramid web app. Right. Like I said, this applies to Flask and Django and other stuff as well. So if we run it, you'll see it's just this starter. But the more important thing is if we go over and we look more carefully at it, let's look at it in Postman. If you don't use Postman for inspecting HTTP stuff, especially APIs, you definitely should. It's very cool. All right, here we go. All right, already remembers this. So if I hit send and I go look at the headers, hopefully I haven't added, oh no, these are the headers being sent. Look at the response headers. Excuse me, we see that there's content length, server type is waitress, in production it would be something like nginx or whatever, but in development it's waitress. And so here you can see there's no protection of cross-site scripting or embedding in iframes or any of the other stuff going on here. So let's go and use SecurePy to add that. Step one, make it a dependency of your project, right? So that when you pip install your requirements, you get that. Now, if you look at the documentation for SecurePy, there's different things you do for each framework, but they're typically like 3 to 5 lines of code. So I've just copied what they had over in their documentation, and you can find it. Here's all the frameworks. Here's the pyramid one. And it says, look, you just import secure headers, and then you create this tween. This is like middleware for pyramid. And what it's going to do is it just says, after the request is done, whatever request you do, go ahead and add on the various headers that you need for this extra security. So in order to initialize this, it's super easy. We just come down here and I'm going to say configure secure, something like that with the config. And let's just go make that down here at the end. So what we need to do is we need to have the name of this. And it's super annoying to me that I can't pass the actual function, because then refactoring tools and whatnot would work better. So infrastructure, hopefully I don't misspell anything, secure tween dot set secure headers. I think that'll do it. I may need the package name there, but I think dot will work. Let's say configure, so config add tween and then the name. All right, let's see if this runs. Super encouraging. Okay. Now let's just go and hit the site again, do another request, and check out the new headers that we're getting sent back. Okay, we're getting the refer policy is no refer, strict origin, strict transport security, cross-site scripting protection, X-frame stuff. All we had to do is that. And now we're conforming to many of those, or we're protecting ourselves against many of those problems that you would have seen in the OWASP security issues. Now, again, it does protect you against SQL injection. Use something like SQL Alchemy or some other ORM or ODM for like MongoDB or document databases. But this is cool. Here's a really nice way to upgrade the security of your site without much work. And as secure.py gets new capabilities, new protections, so will your site. Excuse me, a bit of allergies today. Okay, so this is super easy and very powerful. So this slide right here pretty much summarizes everything you need to do. We need this function, set secure headers, that's going to create and install a tween. And the tween just uses the set secure headers, the secure headers for pyramid on the response. And then we just have to register that with our add secure headers at the bottom one time during app startup. And the link at the bottom here shows you where to go get the docs for your various frameworks. Okay, next one, static content. Let's go back over to that same app and see how it's doing static content. So if you look here, actually right here, we go to our include routes. You can see over here that all the frameworks either implicitly or explicitly will set like some kind of static view. So in Pyramid, we say config add static view. The route name is static. The path is /static. And the cache age is 1 hour. First of all, you'd be better off having that much longer, like a year rather than an hour. So that would be good, but that adds some challenges we'll talk about. But second, Python and Pyramid and Flask and Django, all the non-async frameworks, they really only process one request at a time. And so if we send over a whole bunch of requests for CSS and images and JavaScript, and we try to process it with the underlying framework, whatever, or the underlying web server in production, it won't be Waitress, it'd probably be MicroWhiskey or something along those lines. But nonetheless, you don't want your Python code busy processing that. So what we want to do is we want to go and set up some other higher level piece of our infrastructure to do that. And I have a little tiny bit of setting this up in nginx. So probably what you would have in production is nginx talking to MicroWhiskey, MicroWhiskey running your Python app, scaled out through a bunch of workers. Okay, so if we look at this over here, this is like the standard Nginx stuff, and whatever server you're using may have different settings and whatnot, but we're going to do HTTP2. Also, like here's tip 11, run HTTP2, much better in production. Imagine we had our safer app little thing that but we want to put it in production at saferapp.com. That's probably already taken. Don't go there. I have no idea what's there. But what we can do is we can say, hey, Nginx, first, if somebody requests /static, I want you to gzip all that stuff up, compress it, and serve it as if it was just looking for files out of here, right? So that's pretty cool. You definitely want to do that. And then we can say, set up your error handling. And then at the end, if you don't find anything, why don't you go ahead and pass this off through either a proxy pass or over to a socket or something like that to your actual Python app. So this tip here, tip number 2, is to make sure that you're serving your static content out of the production web server, not out of your Python app. And in our stuff, we're running the static cache at 1 year, 365 days. Now, if you've ever had to deal with, people come to your site and they've cached your CSS file and it looks all sort of wonky after a redesign, or you've changed some picture and it doesn't refresh in the site, things like that, that's not ideal. So what we do is we actually, for every single thing that is a static file in our site, our various sites and whatnot, we always append at the end here this query string, cache ID equals some random number. And it's not just random. This is the hash of the file, static/all.min.css, which is a minified version of like a whole bunch of things. So this way, the URL is always, unique. So the browser will consider this hash of the file as part of the URL. So we can cache it for a year. And then if it ever changes, it instantly changes. There's no make sure it refreshes, there's no wait, and so on. So this is really, really a nice thing to do to leverage extreme caching and yet still get zero staleness. All right, let's encrypt. Now, you're probably doing SSL, but this one's gonna be a quick one. But if you've not used Let's Encrypt, it is so incredibly easy. I'm sure you've heard of it, but this is a service that will let you get SSL certificates for your server for free. And I had known about it for a long time and sort of put off, moving over to it because I had bought some SSL certificates that were good for a couple of years prior to Let's Encrypt coming around. But after I started working with it, I thought, okay, why didn't I do this before? It's so easy, so much easier than even just paying money for one. So these 3 blocks of commands, this is the entirety of the work that you have to do to install an SSL certificate and flip your site over to HTTPS. And this matters for a lot of reasons. Obviously, you want security if you're doing logins, but even if you have zero interest in protecting the information, if you want to run HTTP2, which will make your site run faster, the only practical implementations in browsers of HTTP2 are over SSL. So if you want to have the browser be able to make multiple requests on a single network exchange, like give me these 3 images and this CSS and all the stuff that it does, you need to have SSL. And also Google is rewarding secure sites and punishing insecure sites, both in the user experience and potentially even in SEO. So there's a lot of reasons you want SSL, and literally this is what it takes. So it's incredible to make it happen. So just be sure, if you don't have SSL, just jump in with Let's Encrypt. It's really easy, especially this is the example for Nginx. They've got different examples if you're running something else. All right, here's one that we're going to dive in a little bit further, a little bit deeper. I want to talk about a couple of design patterns. So number 4 is structuring, I guess in high level, it's structuring your application so that you can quickly navigate around depending on what it is you want to do. I need to change the data being exchanged in this HTML form. Boom, I know right where to go. I need to change the data access stuff. I know right where to go. Right? I want to switch from a non-relational to a relational database. I should be required to change one or 2 files, not all over my app. Okay, so that's that's what we're going to look at here. And go here. This is actually going to be looking at this site, which comes from a course that I wrote. The reason is there's a lot going on with this one. And I also have an exact copy of it with Flask as well. So this is the same site, but redone in Flask. All right. And if you look over here, the design patterns, when you go to the repo, it'll just say, here's the link to those two things. So you got to get a different repo because these are full on different apps, but easy to do. All right, so here is that site. I don't want to run its unit test. We'll come back and run those in a minute. This is a fun site. You might recognize, let me run it. Oh, hold on. I'll run it now. I'm not sure what I did to it, folks. Sorry, hold on. Let's just add a new one. See if that'll make it happy. There we go. Every now and then, PyCharm gets a little funky and finds the wrong one. So this. It's worth finding this and making it run, you guys. Hold on. All right, that's good. Just got to reinstall it, sorry. All right, well, that's going. We'll look at this. Now, so let's just have a quick look here. I guess I do want to show you the site. Let's still installing. Well, this might be less fun. Yeah, this is unexpected. All right, I don't need to show you the site. So this is a clone of PyPI, and I've got to reinstall it for some reason. It's going a little insane here. So let's have a look. Yeah, it really is running a lot of processes. 37 processes. Okay. All right, folks, let's close this. And totally start over. Sorry about that. But it's like freaking out and taking over the whole system, which is not going to be good. All right, super. Now it's going to work. I got my fingers crossed. At least I can show you. It doesn't matter if it runs. It's just cute if it runs. All right, will it run? Like a champ. Okay, sorry about that. Now, look at this. This is fun, right? So here's a clone of PyPI, which will be fun. And it has, ability to log in, go see the packages and get help, do all sorts of fun stuff. All right, so in this, we're breaking stuff into, I'm calling it controllers, you can call it views. I go back and forth, right? Because Pyramid and Flask and whatnot, those are basically model view controllers, MVC. So anyway, I call it these. You can call it whatever you like. So these are the views or the controllers. And let's go look at this account one, right? So if we're going to go and exchange data, right? So for example, here I'm going to register for the site. I want to follow the get, post, redirect pattern, or if you look it up at Wikipedia, it's post, redirect, get. But you want to follow this pattern that allows you to process like showing them the form, process them, submitting the form, and then sending them where they're going to go when that is over. So check out how nice and clean this bit of registering here is. That's the entire bit. And the reason it's clean is there's two really cool design patterns going on here. One is this thing I'm calling view models. And the view model is a separate class whose job it is to understand the data that has to be exchanged with HTML of the site, of the template for this request, how to exchange that data, how to validate that data, and how to convert it. Like if they said their age, it's going to be submitted as a string, but you really got to convert it to a number. And for validation, maybe that number has to be between 1 and 100 or something, or 18 and 100 if you're going to let them register. And then we have these services that do all the data access work that you can isolate all the work there. And if we decide at one point we want to switch from SQL Alchemy to MongoDB, we don't need to change this function, right? It would take the same data and internally we would change it, but not. So let's look at those two design patterns really quick. And then also the organization. So here we have our controllers and we have an account controller. And over here, we've got our view models, close up the test, and we have an account. So account controller and account. And then in here we have a register, a login, and an index. Probably should call it index, but over here, right, our view model on initialize, it pulls all the data out of the form and canonicalizes it, right? You don't want to store like uppercase email with a space. You want to always trim that down. And then on the validate side of the post, it'll check that all these things are here. And if you want to add 10 more levels of validation, this code is unchanged. You don't touch the view method. It's entirely clean. The other super valuable thing is this is incredibly easy to test. And we could even set it up if we wanted to pass additional information and not even pass the request, right? We can just create one of these objects and write a unit test against it without trying to fire up the entire web infrastructure to trigger the execution of that view method and whatnot. Now, sometimes we want to do that. We'll actually do that in another tip as well. But these view models are super cool for both creating a kind of a firewall of change. So as you change the HTML form and more elements and validation goes in, you don't have to change your view, as well as allowing you to test. Oh, I see some questions. Yeah, so there's a couple questions going back just a little bit. Two, let me answer them before we get too far away. One was, what is the function of me do? Like, why did I do this? Why did I write this function? Because this will become like a huge mess. So right now, this is so incredibly simple, right? That it's kind of weird to have this. Yeah. Like I would also do this. I'd come over here and say, let's make this a method. I would call this init includes or something like that, right? And I would add this. And what you'll find is, I think this also should probably be in there. But in like our real apps, this file is probably 300, 400 lines long. And it's broken into a bunch of these little types of functions. And as it grows, so it's certainly not required here, but I don't know, my instinct is to just do it like with a view towards it's going to be much more like, because you're going to have an initialize the database, initialize things like email, inbound, outbound email. Like there's just going to be like layers of stuff that you're going to need to go through, initialize secrets and whatnot. And then the other question was about that cache ID stuff here. No, I just wrote a little function, little class that we use in our code. I could, if you're really interested, shoot me a note. I'll be happy to share it with you. Basically, it just looks at the file and it says, if you're asking for this file, we'll give you the hash of it as this. Basically, it'll compute the hash. But in production, it doesn't recompute the hash unless you restart the site, just to make that a little bit quicker. Okay, that addresses the two questions. So let's go back here. So we've got these view models, and let's look at the user service real quick over here. This is similar in sort of, not in structure, but the similar idea. Like we want to put all of our data access code over here and hide it away. It can be evolved, it can be changed, there can be more validation without having to come back. You don't want to just do your queries, obviously, right there. Again, it can be more tested. If you want to switch from SQL Alchemy, which is what we're doing here, to something like Mongo Engine or something else, I don't know, Redis, whatever, you can go and do that here and it doesn't have to change. So The other thing, I guess, is just the overall structure, right? Like a lot of frameworks, I'm looking at you, Flask, that says Flask is so awesome. You can have just a single file, app.py. You can put everything in there. That is true, but it doesn't mean you should. Okay, so having a lot of structure here, again, like our templates that we use also have this same structure. So like if I'm looking at this file, I know exactly that's related to the account controller and the login method on that controller, and here's its corresponding validation data exchange bit. Okay, so design patterns and whatnot, very, very, very helpful there. Let's get back down to this one. All right. So here's the link to those things. I'm happy to throw those into the end conversation, but they're also in the repo that I already talked about. So view models, services, idea of like, here's all the stuff that talks about users, or here's all the stuff that deals with email lists. It could be a database, but it doesn't have to be. It's just like core functionality. And then this organization across these layers. All right, this one will be quick, a nice one. Now, number 5, if you find yourself lost and you don't know where to go, something's crashing, something's going on. There's 2 things that you need. You need to be able to, one, go back and see that these things happened, or see what is happening in your site in general. So log in, and then you need to be notified about it. I need to be told there's some user running into a problem. More than once on our Talk Python training, where we have the courses and customers buying stuff, I've had errors where I got notified before the error, the user ever got a chance to write me an email about the error, and I fixed it. And I was, writing them a message back, and I finally got that support email. Hey, I'm trying to do this thing and it's crashing. I tried to buy a course, or I tried to log in or whatever. And I'll, if it's an actual bug, I've actually sent them that message, said, I saw you having this error. We fixed it. Please try again, before we even got the support request. And wow, that's crazy. So you want to be able to do that for your users, right? You want to be able to say, I saw there was a problem, but we already fixed it. So for logging, I'd recommend Logbook. It is so nice and simple and clean. You can use Python's built-in logging if you don't want dependencies, but it's a web app, so you already have dependencies. Might as well take a better logging experience. And right now I'm using Sentry for the notifications. So if there's an error, it'll get posted to Slack and to email and things like that, like in real time. And what's really cool is it has like, here's the email of the person who ran into the problem. Here's the local variables in the call stack. So I can actually go, oh, they typed in this value and we should have converted that from a string to an integer, or whatever the issue is, right? So definitely think about having that there. Also, not storing secrets. Storing secrets is bad. Why? You've heard, okay, you shouldn't check in like your AWS secret access key to GitHub. Why not? Well, if that code ever becomes public, it's going to be bad. And you might think, Michael, there are tons, so many millions of projects on GitHub. Who's going to know? I did a quick search, and this is the things that came up on on the front page of Google without scrolling. Over on GitHub, there's this thing called Trufflehog, and it searches through Git repositories for high entropy strings, things that look like they might be secret keys and secrets that they know, digging deep into the commit history. So if it's ever in the repository, it will be found. There's another one called Git Leaks. It scans for secrets using regex and entropy levels. There's also this thing called Git, and it finds secrets in real time. Git finds secrets and sensitive files across GitHub code and gists committed in near real time by listening to the GitHub's event API. So yeah, you don't want to check the stuff into GitHub. Obviously, you look at some of these, undoing that is going to take some more work than just checking in a new version that doesn't have it. So first of all, secure is about layers. Secure.py doesn't fix everything, but it does help. For example, there's other layers that you want to have. But in this world, you could store these in an environment variable that is not obviously checked in, right? You only available on the server, and in production you have different ones. Or you could even have like a JSON file that is loaded and parsed, but that's never checked into GitHub. But those are still somewhere on disk, right? Those are in a bash RC or in a JSON file, potentially readable. So you could encrypt them and then store the key somewhere else. So for this, you might use cryptography.fairnet. This is a really simple Python library for encrypting and decrypting things. You could store the encrypted result from there and then decrypt it using the key. You could use a key vault, something like Microsoft Azure. A lot of the cloud services have places to put these secrets that are then encrypted. Right from 6 Feet Up, Calvin Hendricks Parker recently blogged on using 1Password automation for storing these secrets. And as you saw, I was running 1Password when this thing, when I switched over between apps. And 1Password is awesome. So this, I totally think that's a neat idea. And then activating these environment variables and getting this stuff set correctly can be a pain, especially in like development, right? In production, you probably have a server dedicated to this. Maybe you're running a bunch of stuff, but you probably have a bunch of small servers rather than one huge one. But dir-env allows you to activate and deactivate environment settings, environment variables and whatnot, as you navigate directory trees. So if I'm in like one project, it'll automatically activate those environment variables just by virtue of being there in the terminal. And then if I go back out of there, they deactivate, and I go somewhere else, new ones activate, and so on. So putting all this stuff together might come up with some really good stuff. But the main takeaway is don't put secrets, obviously. And here are some options for alternatives. All right, how are we doing on time? Yeah, we're doing great. So you may have heard of testing, and you might think this is something I should do. We all want to write unit tests. However, there's usually going to be some parts of your site that are not really tested, right? And there's what I'd like to do in reality for having 100% code coverage and all sorts of good stuff, but there's also potentially other issues. And those issues might be stuff that's super hard to unit test, like the data that I'm passing from my view model and the data that the HTML template expects are inconsistent. And so under this scenario, I'm going to pass a none value and then try to dereference that in the template. How many people are unit testing their HTML templates accurately, right? There's just all these little edge cases. So what I'm going to tell you for this trick, this tip, it feels like a trick, it's a tip, is something that will exercise most of your site, probably not all of it, but most of it, and do sort of end-to-end testing. And it's not meant to replace unit tests, but it's going to give you, it's going to see if most of the site will make it through alive, right? So the idea is what we can do is we can take a sitemap. You should have a sitemap anyway, right? Like if we go over here, we look at the sitemap for us, it has like all of our static elements and then a bunch of dynamic elements like marketing pages. And I mean, look at that scroll bar. There's like 4,000 pages here, but it like shows every single thing that could be on the site. So what is this tip? This tip is this page, this easily parsable document shows you most of the pages on your site, at least the public ones that don't require authentication login. Just request them. So let's go look at that. So over here, if I run this thing, it was already running, but hey, it's more fun if I run it twice. So this one also, this is that little example. This is a sitemap.xml, I believe. Yeah. Now this one, quite simple. Actually, it does have like all the packages and stuff, but like other than the packages, it's quite simple. So what does this look like? This is both, I have examples of this both in Pyramid and Flask and either of those two respective apps we talked about. So if we go over here to tests, it's super easy. All we got to do is say, create a web app. This is just standard way to create the a web app from web test in Pyramid. Like when you create a new Pyramid app, like this stuff is basically written. So we're going to set this global app that we can use. Then we wrote some code that PyCharm is not misspelled and no sorcery. It does not need any help, but here, so it's going to go and get the sitemap. And what it does is basically does a unit test request against sitemap.xml. And then it just rips through and says, all right, let's go and do a little XPath expression against the XML using element tree. And then just find all the URLs and then it just goes through them. And what it actually does is, because we have 100,000 slash project slash whatever, you know, slash pyramid slash SQL alchemy slash Flask slash whatever, really it's the same template. So we don't need to request it 100,000 times. So we have this little bit of code that says, like, this data driven bit, we only really need to like hit slash project slash once. Okay, so that limits it to a much smaller one. So if we go run these tests, let's see if this works. There's some warnings. No, it does not like. Here, I wonder if that's that weird issue that I ran into before. Let's just run it again. Oh, I gotta do the, remember how I had to reinstall it because the virtual environment went wonky? I need to do this one. I need to install the web testing tools, like web test and stuff. So hang tight for just a second. It doesn't take long. There we go. All right, now to run. So there's a bunch of warnings and stuff. Don't worry about that. That's just Pyramid saying I should upgrade something. But look, all those tests ran. If we go down here, you can see it tested all these URLs. And the way it works is you just say, get it, and I expect a 200. You can also say, well, this one is going to do a redirect over there. So you could say status is 300. But like if I said I expected a status 302 and I try to run this, it's going to crash and say, no, I got a 200. I don't know what's going on. You know, it's like a lot of, it's quite verbose, but bad response 200, not 302. Okay, so this is the assert right there. It's kind of an implicit cert, if you will. But we've just exercised the majority of our site. And as we evolve our sitemap, we'll now do that. So again, not a replacement for unit tests, right? You should have things that test like, you know, validation and other things that you're going to test. But also throwing this in there, this is going to be a really nice catch-all that brings a lot of things together, like the data being passed from Python over to either Chameleon or Jinja. All right. So sitemaps, and it's super easy. Write the code to get the sitemap. And by the way, you might have noticed this replace. Technically not possible, but personally, I hate XML namespaces. When I'm trying to do XPath queries, I always forget how to use them. So if you just erase the XML namespace, you don't have to worry about namespaces. It makes the other side simpler down here. And so you just go and find all the URLs using a list comprehension and an XPath query, and then you just go and request them. That's it. Right, but this is a really nice way to just go like, let's just make sure the site kind of hangs together, that I could at least at a minimum request the pages, and then let's add additional testing. All right, also site speed. Next one, number 8, site speed. How fast do I have to be? I have 7 minutes-ish. We can do it. So site speed, having your site fast is not just a nicety. The speed at which your site responds and appears to be, the way it interacts with users affects many things. There was a study that said something like, for every 100 milliseconds of latency, Amazon.com loses 1% of their business, right? So if you could add 3% back by just making your site faster, that would be good. But also think about the sites that you interact with. If you go to a site and it takes 6 seconds to go from page to page, it just feels like crap. On top of this, Google is ranking sites higher if they're faster. That's pretty awesome. Now, Python is well suited for this world. Like, you know, you hear people talk about, well, Python's not that fast because I'm trying to do like this this iterative computation of like vector forces and like some model of like planets, who knows, and it's not as fast. It doesn't matter. What web apps do is they take stuff over the network, they do a little bit of processing, they talk to things like other APIs and databases and stuff, and for that, Python is ultra fast. So stuff on our sites like Talk Python training, you know, if it's over 100 milliseconds server processing time, like it's on the verge of broken. Like we're like, how do we fix this, right? This should be 10 milliseconds on the server. But what surprised me is that seems fast. Like I know that 10 milliseconds seems like it should be good. But if I go to Google, you can go to Google and ask. So let's go over here. You can go to Google and you could type in whatever it is you want here and hit go. And I did this and it said, your site is slow to moderately at the bottom of okay. And I thought, what the heck is going on here? Because what if I make it 10 to 5 milliseconds? It doesn't, it's not really going to matter, is it? I mean, the ping time on the network is way, way longer. So there's actually a ton of recommendations. So if I run this here, I had it really high and they've added some additional checks that I have to go through. I spent like days making this work here. So give it a second. Now 75 is, it's okay, but they give you a mobile and a desktop. And this used to be really high, but they've added some more checks, which we'll talk about in a sec. But on the desktop one, we're golden. Okay, we're totally golden. But when I first put this in here, this was like 50. 49 or something like that. And it blew my mind. Let's look at this one that they say needs more help. They give you all sorts of feedback and stuff here. Like, look, here's how long it took. And here's what it looks like under all these scenarios. And here's some things you could do. Like I could rewrite all these images in terms of JPEG 2000 or WebP. Other ones are if the browser, especially on mobile, has to resize images. If you have huge images, but you're showing a small version through CSS, so like that's a lot of computational work and it makes it feel slow before the user actually sees that. So here's like, you should serve images out of the right size. And right, for example, this one, most of them are fine now, but there's a few I guess I could work on. Remove unused CSS. So there's just all these ideas, right? Like this is a minification of Bootstrap and a bunch of other stuff. So I'm not doing it. That's why it's still here. It's too much work to like figure out what subset of Bootstrap I'm using to get that little boost. But definitely throw your site in here and think about how the users experience your site. The one sad thing is it doesn't seem to really embrace the caching quite as much as I think it should. All right, so this is definitely a good one. Site speed, throw it in here. By the way, you saw I got 99 just then. When I took the screenshot, I got 97. Like you should expect a plus or minus 5, maybe even plus or minus 10, depending on the internet. I don't know. There's a lot of variation still. Okay, this one is a super good tip that I really like, and it only applies if you have servers, like infrastructure as a service that you run your stuff on. If you're running on like Heroku or platform as a service, it won't be relevant. But when you log into your server, your production server, what is the goal? The goal is to manage your application. You want to go and configure the Python settings. Like if I pip install a thing, the chances are it's for that application. So what you can do is you probably want to have a virtual environment. So in case you need to roll it back, you can wipe it away and reinstall it without recreating the server altogether, assuming you're not using Docker. So just go into your zsh.rc or your bash.rc and add a line at the end, source, activate your virtual environment, like whatever your virtual environment path is. And when you log in, like here's if I log into Talk Python Training's server, you can see there's a VNV active. So that is the one that's mapped over to the continuous integration story behind that whole site. And this just means you log in and 99 out of 100 times, you've already got the right setup that you want to work with. The few times you may want to change the environment of the server, just type deactivate and you're good, right? So this is a really nice trick here. And then final one, dependencies. We got 1 minute, dependencies, I'll be quick. If you pip install something, you get the latest. Unless it's already installed, then it doesn't update. If you say -- upgrade, that's awesome, but it doesn't update the dependencies. And if there's security issues and you pin your version, GitHub will actually give you a security warning, PR. But if you don't have an emergency, you're going to be stuck in the past. So I recommend using either Dependabot or PyUp. Dependabot is free and is built into GitHub. It's a little bit more annoying how it works. It gives you like a zillion PRs. Like every single dependency gets its own separate PR versus the way that PyUp works. But PyUp costs money if it's not open source. So they both have their pluses and minuses, but definitely employ something like this to make sure you're up to date, getting all the security updates, but also all the other ones. And that's it. Thank you so much for coming to my talk. If you want to get more of this kind of stuff, listen to the Talk Python Me podcast or which it's just me and guests, or Python Bytes, which is Brian Ocken and me. He's my co-host there. And if you want to get more Python education and training, some of the stuff we talked about is interesting, check out Talk Python Training. And that link in the bottom left there, that is the link to the GitHub repo. Thank you, everyone.